We're going to take a look at a couple of calculations that involve heat. In neither of these calculations will we be dealing with any kind of a chemical change, nor will we have any kind of a phase change involved. There's just heat being transferred from one material to another, and we're asked to calculate some information. So this first question, we have how much heat is needed to raise the temperature of 20 grams of water by 10.6 degrees C, and we are given the specific heat of water, which is 4.184 joules per gram degree C. So in this problem, we see that we have a good application of our equation Q equals mc delta T. So what we're going to do is we're going to list out our knowns and our unknowns. So we list out the four variables in our problem, and we then pull our information from the problem. And so we read it right off the bat. The question says, how much heat is needed? Well, we know the variable for heat is Q, which means that's our question mark. That's the thing the question is asking about, how much heat. And we see that it's how much heat is needed to raise the temperature of 20 grams of water. So we see 20 grams, that's our mass. So we write that in. And we're trying to increase the temperature by 10.6 degrees C. That is our temperature change. So our delta T is 10.6 degrees C. And the specific heat, that variable is represented by C. And so for our value of C, it's 4.184 joules per gram degree C. Of course, we're writing our values, which means we're writing down our numbers as well as the units that go with them. At this point, we would normally look to see if we need to rearrange the equation, and we see this time we don't need to rearrange the equation. It's already in the format of our unknown, our Q, is equal to something. And so now we just know that we need to plug in our value for M, the mass, and we plug in our value for C, the specific heat, and we plug in our value for delta T, and then we check to make sure that our units cancel. We see our grams cancel. We got grams above and below the line, and likewise we have degrees C below and above the line. So those all cancel, leaving us with the units of joules. So now we can calculate our final answer. Now we will go on to our second example problem. What will the temperature change be if 947 joules of heat are added to 76.4 grams of a material with a specific heat of 0.607 joules per gram degree C? So again, we see that we don't have any kind of a chemical change going on. We don't have a phase change. We're not talking about anything boiling or condensing or freezing or melting. And so we look and see this is an application of Q equals mc delta T. So we will list out our four variables again, and then we will look at our problem to pull out the information. And right from the start it says, what will the temperature change be? So the question mark goes with the delta T, because that's the question. What's the temperature change? And it says that 947 joules of heat are added. Well, we know Q is our variable for heat, and so we'll write our 947 joules in with the Q. It tells us the mass is 76.4 grams, and the specific heat represented by C is 0.607 joules per gram degree C. Now this time we find that since we're trying to solve for delta T, we want to get our equation to say delta T is equal to something. And we want to get that delta T by itself. So looking at our original equation of Q equals mc delta T, we see to get delta T by itself, we're going to need to divide that right-hand side of the equation by both the mass M and the specific heat C. And if we divide the right-hand side of the equation by mc, we also need to divide the left-hand side of our equation by mc. And that cancels out the M and the C on the right-hand side. And we can rewrite our equation to say that delta T is equal to Q divided by M times C. And now we're ready to go ahead and plug in our values, our numbers plus their units. So we say delta T is equal to, and we put in our number for Q, then 947 joules. We put in our value for the mass and our value for the specific heat. Now we can check to see what units cancel, and we see we have joules above and below the line. They cancel. We've got grams. They're both down in the denominator, but we have one above the line and below the line down in the denominator. And that leaves us with units of degree C, which is in the denominator of the denominator. Or we could say 1 over degree C, and that will just end up being degree C. So our final answer is 20.4 degrees C.